Hello, my lovely FRM friends, and welcome to our foundation section of the final review. So for foundations, I've decided to focus on the most technical part of foundations, which of course is the bit surrounding modern portfolio theory, performance evaluation, multi-factor models, Farmer and French, all that exciting stuff. And of course, you know that foundations is 20% of your score. Of course, you know that foundations will have a lot of definitional readings that you can plow through in your own time. But I want to remind everyone, of course, is that even though once you've covered all 4 books, you might come back and think that foundations probably one of the easier or maybe the easiest of the 4 books. Please don't underestimate it. Please study it. Please practice a lot of questions in order to score healthily on exam day. But let's get started with our modern portfolio theory. So you can see here that I've got the portfolio possibilities curve on the left-hand side. And so this is plotting my returns per unit of risk. And here the risk measure is standard deviation, or sigma, or S if you prefer to denote it as sample standard deviation, but we are looking at return per unit of risk, and we are building essentially different portfolio combinations that would minimize risk per unit of return. Now, we very quickly realized that part of this is efficient and part of this is inefficient, part of this curve. And in fact, the efficient portion of the curve starts at this point here, B, which is the global minimum variance portfolio. And it then goes up to C and D. So this is the bit that is efficient. The reason why this is efficient, oops, that's not great, of course. Let's just mark it like that. This is the efficient bit. And the reason why this is efficient is because we are maximizing return per unit of risk. Nobody will actually want to hold point 8 because that point will give me the same amount of risk, approximately the same amount of risk, but much less return compared to the point vertically above it. Okay, so from the efficient frontier, we then move to the right, and we can now combine the efficient frontier with the risk-free asset. Remember, the risk-free asset is perhaps a government bond, US Treasury, German Bund, Italian BTP. So it will have positive return, at least in the textbooks it will have that. And then the volatility or standard deviation or risk will be 0 because it's considered risk-free. It's not considered volatile. Of course, we're using the 3-month T-bill here, perhaps as a proxy for a risk-free asset. And we're going to be combining that asset with the efficient frontier in a special kind of way. We will be selecting a particular portfolio in the efficient frontier, which will be the tangency portfolio. In other words, the portfolio where the line touches but does not cross the efficient frontier. And because of Harry Markowitz's homogeneous expectations, that tangency portfolio will become the market portfolio because everyone will have the same assumptions and everyone will end up holding the same set of investments, which are then defined as the market portfolio. So the capital market line is the line that connects the risk-free asset with the market portfolio. And you can see here that the CML dominates the efficient frontier. In other words, by bringing in a risk-free asset into our risky portfolio, we have improved our risk-adjusted rates of return because a risk-free asset is not correlated with the rest of